Okay, 6.2, unit circle and a trig of real numbers. This will be day number 5. In day 5 video, what you're going to see is the most important table that you're going to need to remember. From here, you might as well start studying it right now as soon as we get it down, because you're going to need to know these values off the top of your head and rather quickly. So we'll look at the table. We're going to take a look at the completed unit circle, because now we're going to be able to draw the entire circle. And then what we're going to do is start evaluating some trig functions without our calculator. So let's get started. Okay, based on the activity that you did yesterday, as you watched the video, these should now look familiar, right? We talked about yesterday a 30, 60, 90 triangle. We talked about a 45, 45, 90 triangle. And if you remember from a couple of days ago, we know everything there is to know about 0 and 90 degrees, because those are our quadrantal angles. What is a quadrantal angle again? Hopefully you remember at this point what a quadrantal is, and I don't need to really talk about that. So, if I think about it, I know sine is the y value when we look at the unit circle, cosine is the x value, and tangent is y divided by x. Well, if I think about the unit circle at 0, I'll start here. I'll start at 0 degrees and at 90 degrees. Think about the unit circle. If I were to draw that, you kind of have a circle that looks like this. It's a pretty good circle, I'm not going to lie. 0 degrees, I know everything there is to know about this point. I know it's 1, 0. 90 degrees, I know everything about this point. It's 0, 1. So if you remember correctly, if I said to you, what's the sine at 0 degrees, I'm basically asking you what is the y value at 0 degrees, and you would tell me that that would be 0. Sine of 30 degrees, well, based on the activity that you just did yesterday, sine of 30 degrees, opposite over hypotenuse, you get 1/2. Cosine 45, or sine 45 degrees, you get root 2 over 2. I think I'm doing all of these from the activity yesterday. Sine 60 degrees, you get root 3 over 2. And now remember, sine of 90 degrees, now I'm asking you what is the y value at 90 degrees. And you would tell me that that's 1. Cosine, now I'm asking you what is the x value at 0 degrees. 30, 45, 60, cosine, we did those yesterday. And 90 degrees, what is the x value at 90 degrees? Okay, you should be able to do that. Tangent, well, I take simply y divided by x, and that gives me that number. Tangent of 30 degrees, based on our activity yesterday, you get root 3 over 3. Tangent of 45 degrees, you get 1. Tangent of 60 degrees, you get root 3. And again, tangent of 90 degrees, y divided by x, and you get undefined. Ladies and gentlemen, I cannot tell you how important it is that you know this table. Ask any of the kids that are in other classes. They will tell you you must know that table. Guess what? Your next pop quiz will involve probably this table. Hint, hint. Oh, sorry, I had something stuck in my throat there. Must have been, I don't know, cat hair or something. I don't know. Maybe dog hair. Anyway, so table, you're going to need to know it. Study it. Study it. Study it. Okay, got it. As we keep going, let's take a look at the unit circle one more time. Notice now I've taken your quadrantal, which was this thing here, right? We know everything there is to know about these 4 points. We know what those coordinates are. We know what those coordinates are, and we know the radians. We know the degree measure. So get your stuff together and understand what the quadrantal is. But I wanted to show you, look at what we did. We basically have taken this first quadrant. I know that point's 1 comma 0. I know this point is root 3 over 2 comma 1/2. Think cosine, sine. Keep going. Cosine, sine, cosine, sine. And I have this point 0, 1. Part of your responsibility right now is to pause your video, head out to the internet, and complete the rest of this unit circle. When I say complete it, I want all of these coordinates done. What are the coordinates, meaning what are the points, what are they labeled, and then I also want you to fill out all of the radian measures. What is this in radians? What's 30 degrees in radians? What's 45 degrees in radians? And I want you to put that on the inside. So I'll do the first couple with you. I know that that's 0 radians. When I get all the way around, I know that's 2 pi radians. 30 degrees, I know is pi over 6. 45 degrees, I know is pi over 4. 60 degrees, pi over 3, and etc., etc., etc. You fill out the rest of the unit circle from here. Your responsibility to make sure that that is done before we keep going. Alright, ladies and gentlemen, please put your thinking caps on because holy crap, here it comes. Now we're going to do all of this without a calculator. I'm telling you right now, your simple trig chart, your reference angles, and that table are the most important things to know in order to do these problems here. Because, watch this, I'm going to model and I'm going to show you how I do each one of these. So for the sine of 150 degrees, first one I'm going to do, I need to first of all figure out which quadrant it is in. So 150 degrees I know is in the second quadrant. Thinking about my simple trig chart, I know that the sine is positive in that quadrant, so I know the sine of 150 degrees, the answer is going to be positive. Well, in order to do this without a calculator, I need to figure out, well, what is the reference angle for the sine of 150 degrees? Hopefully, you're able to tell me at this point that the reference angle is 30 degrees. So I'm telling you that the sine of 150 degrees and the positive sine of 30 degrees are going to be the same answer. Well, from my table, I now know that the sine of 30 degrees is 1/2, and therefore the sine of 150 degrees is also 1/2. If you don't believe me, use your calculator this one time only, type in sine of 150 degrees, I bet you $1,000 you get 0.5. So, do you see how important it is going to be that you understand A, your simple trig chart, B, your reference angles, and C, you have to understand your table. You have to know it because I will not let you use a calculator for these. So, let's practice. Let's do another one. Number 2, cosine of negative 135 degrees. Step 1, what quadrant is it in? Well, it's in the third. Step 2, my simple trig chart tells me that tangent is the only thing positive in that quadrant, and therefore the cosine of negative 135 degrees will be negative. The reference angle for negative 135 degrees, the reference angle would be 45 degrees. So again, I know that the cosine of negative 135 degrees, if I were to type that in my calculator, and then I were to type the negative cosine of 45 degrees, I'm going to get the same answer. But notice, without a calculator. That means I have to know my table. Cosine 45 degrees, so I'm going to look at my table. Cosine 45 degrees is negative root 2 over 2. Alright, hopefully you're picking up on what I'm putting down, because this is no joke. Tangent, 7 pi over 6. I'm going to go a little bit quicker. Third one, 7 pi over 6. I am so unbelievably impressed with how far you have come with your radians that I am confident that you know that this is in the third quadrant. Your simple trig chart, tangent is positive in that quadrant, so I know the answer is positive. My reference angle for 7 pi over 6 is pi over 6. So I think from my table, tangent of pi over 6 is root 3 over 3, and voila, there is my answer. Number 4, negative pi over 3. Well, fourth quadrant. My simple trig chart, cosine is the only thing positive in that quadrant, and therefore sine has got to be negative. Reference angle for negative pi over 3 is positive pi over 3. Sine of pi over 3 from my table is negative root 3 over 2, and voila, there are my answers. Ladies and gentlemen, please get your table down. If you need to, make note cards, quiz each other, test each other, constantly keep that table in your mind, because it's going to be so important that you know that as we keep going. Hopefully, questions, comments, concerns, let's get them on this on the next screen. And good job. Well, hopefully, good job.